Welcome back. In this video, we're going to visualize one of the vector examples from the previous lecture here in Unreal Engine. The first thing I'd like to do is draw a coordinate system so that we can get a little bit of a visual representation of our coordinates. Let's go ahead and open our level blueprint. So we'll go up here to the drop-down, select Open Level Blueprint. And I think I'm done with our print string that's printing our delta seconds value. So I'm going to go ahead and delete those nodes. And up here in Begin Play, I'd like to draw a debug coordinate system. So I'm going to use a Draw Debug Coordinate System node. We're going to hook that right up to Begin Play, and we're going to draw it at the origin. And for the scale, I'm going to scale this up to 1000. Now for duration, I'd like this to hang around for 10 minutes. So I'm going to put 600 seconds for the duration. And we'll give this a little bit of thickness. Let's give it a 3 for the thickness. Now we can play test and check out what this looks like, and we can see the coordinate system here. Now it's kind of fighting with that location where the floor is, so I'm going to move the floor down just a bit. We're going to select that floor and just move it down by 10 units, so we can see that its Z location is -10. Now pressing play, I can see that coordinate system more clearly. And I'd also like to move the player's start away from the origin so that we don't have to move that default pawn and turn around to look at it every time. So I'm going to turn it around facing that origin location. And now if we press play, we can see it. So I'm going to go ahead and move it just a little bit more, move it up, so it's a little bit more convenient for us to look. Now I'm going to move that drone out of the way just a little bit. I have my gizmo showing me local space, but I can go ahead and switch that back to world space. So now that we have our coordinate system, I'd like to be able to visualize locations in space so that when I press play, I can see some debug shapes at various locations. So to make that easy, let's make an actor that will draw a debug shape at its location. So in the content drawer, let's go to our blueprints folder and right-click to make a new blueprint. We're going to select blueprint class, and this will be based on the actor class. I'm going to call this BP_debug actor. And let's double-click to open debug actor. Now, when I open up a blueprint editor, I usually like to have my tab docked right up at the top next to our map tab and any other tabs that are here. Now, every time I open an editor, I don't want to have to dock it up at the top here. And there's actually a setting in our project that will force all new windows to open docked up at the top, so we don't have to click and drag and dock. To set that setting, we have to go to Edit and Editor Preferences. And what we're looking for is Asset Editor Open Location. It's set to default, but I'm going to change that to Main Window. This will dock our tabs in the main window so we don't have to click and drag every time. And I usually set that setting for all of my projects. But that's just a preference. I'll go ahead and close Editor Preferences and go back into Debug Actor. Now I'd like my debug actors to constantly be drawing a debug shape wherever they are. So I'm going to go to the event graph and I'm going to draw a debug shape. Let's right-click and type Draw Debug. And let's get some practice with another one of these debug shapes. I'm going to choose Draw Debug Box. Now I'd like to draw this every frame in Event Tick. This way it'll never go away. And when you draw a debug shape in Event Tick, you can leave the duration set to 0. And this will draw it for a single frame over and over again in Tick. Let's hook that up. And we're going to draw this debug box at the actor location for the debug actor. So we can get the actor location with getActorLocation, and we can hook this vector in as the center. Now the box extent has 3 values. It's also a vector. And this is how far the box reaches in the X, Y, and Z directions respectively. So we can see what this looks like with, say, 10 in each of the X, Y, and Z. And we can give this some thickness. We'll set this to 2 for now. And the line color is black by default. I'm going to change this color to red by opening the color picker. And I'm going to drag the saturation all the way up to full and drag the value all the way up to full, and this gives us a pure red. I'm going to click OK, and we can see what this looks like if we drag in a couple of debug actors. I'm going to go ahead and open my content drawer and bring in a debug actor and move it up and press play. And there's my debug actor. I can see that it's drawing its debug box, and this is what it looks like with a box extent of 10. Now, its actual location is in the center of that box, and we can prove that by drawing a debug sphere in the middle. So I'm going to add a draw debug sphere. We're going to hook this up right after draw debug box. I'm going to make its radius really small, like 5, and we have to hook something in for the center. Now, we could take the output pin from getActorLocation and drag it straight in, but that gives us a wire going behind draw debug box, and this is a habit that tends to make our blueprints get messy in the long run and disorganized. So rather than dragging lines from one node over to multiple nodes like this, I typically like to duplicate nodes and keep the number of reaching wires to a minimum. So with getActorLocation selected, I can use Control-D to duplicate it, and I'll plug the actor location straight into the center for draw debug sphere. Now we can play test, and we can see that that sphere is right there in the center of the box. So now we have this nice debug actor that we can use as a tool to represent locations in space. And we can drag in multiple instances of these actors. I'll go ahead and bring one in so that we have 2, and we can play test and see them both. Now our debug actor is drawing its box with the color red. We're hard coding this value in because we've just chosen a color here on the node itself. But notice that the color has its own data type. It's called linear color structure. And we could pass in a value with a wire. To do that, we need to have a value to pass in. And we can actually store values on actors as variables. A variable is a nice way to store a value that we can use here in the event graph and hook that value in to nodes that require that data type. Now we need a linear color structure value, and we can create a variable over here in the My Blueprint panel under variables. We can hit that plus variable icon, and we can give our new variable a name. We're going to call this variable box color. It's important to keep your variables descriptive so that you can know what it is based on its name. Now, as we know, data in Unreal Engine is identified by its data type, and each data type is associated with a color. The data type that we want is linear color structure, and we can change the data type for box color by opening the drop-down next to it. We can see that its data type is set to Boolean type, and we'll talk about what Boolean type means later. But expanding this drop-down, we see a number of types and their respective colors, along with a set of drop-downs, and these categories are for more complicated data types. The one we want is called a linear color structure. The different structure data types are under structure, and there are quite a lot of them, so we'll make it easy by searching for linear color. And here we see linear color. It's one of the structure data types. We're going to select that to change box color to the linear color type. So now we have a box color variable. This variable belongs to the BP Debug Actor class. So it's now available in the event graph for the debug actor. It will not be available in any other actor types, such as our drone actor. This box color variable belongs to debug actor. Now we can use it in the event graph in a number of ways. We can click on it from here under the variables section and drag it in and release. And we have 2 options, get box color and set box color. If we choose get box color, we have a node with an output pin, allowing us to use this box color value, such as by dragging a wire from it and hooking it up to a node like this. But what color does box color contain? Well, we can check the details panel for that. The details panel shows us its name, its variable type, and at the bottom we see the default value. Now notice it says, please compile the blueprint. We can't see its default value until we compile. You see, blueprints ultimately have to be compiled down into a form that the machine can read, and that's what this compile button does up here at the top. Now, we haven't been using this compile button thus far, and that's because whenever we press the play button, all of our blueprints are automatically compiled for us. But there are some things that we need the blueprint to be compiled in order to do, and to set our new variable's default value, we need to compile to do that. So if we press compile, now our new variable is compiled along with our actor class, and this allows us to set a default value for box color. Now we can expand the dropdown and adjust the RGBA values individually, or we can select the color rectangle and choose a color. So I can pick a color with the color wheel, click OK, and now box color is this turquoise color. And if we go ahead and play test, we can see those boxes drawn at that color. And the cool thing about this is if we change box color, we change the color that we draw our debug box at. Now, what if we like our box color to be different for each actor instance in the world? Well, we can go back into our level and we can select one of our debug actors. Now, if we search the details panel for the box color, we're not going to see anything. Why don't we see the box color variable on instances in the world? Well, the reason is because we have to specify that that variable should be editable on instances in the world. And to do that, we go back to our actor blueprint and we take our box color variable, we select it, and in the details panel, we have an option, instance editable. This allows this variable to be editable on instances in the world and not just on the blueprint itself. If we check that checkbox, notice that we now have the yellow question mark on the compile button, and hovering over, we see dirty needs to be recompiled. Now, before we go and click on that, let's go back to the basic map. And I have a debug actor selected in the world. I still can't see the box color, even though I set that variable to instance editable. But back in debug actor, if I compile and go back to basic map, I can now see the box color. It's now available to edit on instances of our actor in the world. So there are some changes that need the actor to be compiled here in the editor before we can make those changes. Now, instance editable is a checkbox in the details panel, but it's also an icon right next to the variable name here under variables in the My Blueprint panel. If I click on that eye icon, it's now closed, and instance editable is now unchecked in the details panel. And I can click the eye icon again, and instance editable is now checked. So this is a shortcut that allows us to make variables instance editable without going over to the details panel and checking that checkbox. And every time we make that change, we have to compile, so that change will be reflected on instances in our level. So now that box color is a variable that's instance editable, we can change it for individual instances of our debug actor. I can change it for this one here by selecting the color picker, and I can give it a red color if I like. And then I can select this other actor over here. Notice it's still turquoise because its box color hasn't been changed. When a variable has a default value in its blueprint, but we change it on an instance, we say that we've overridden that value. So we're going to override that value for box color for each of these individual instances of our debug actors. So this one has a blue color and this one has a red color. And if we play test, we can see that reflected in their debug shapes. That's because we're using that variable to drive the line color on our debug box. So now we have these debug actors, and we can change their colors for individual instances, at least for their debug boxes. Now I'd like to recreate our vector example from the previous video. Remember, we had a sniper up at 007. Now, Unreal Engine units are centimeters, so they're very, very small. If we take our debug actor, the one with red for its box color, and we clear the search bar, if we set its location at 007, that's going to be very close to the origin. As you can see, it looks like it's at the origin. It's actually 7 units up, but those units are so small that it's kind of hard to see. So we're going to work on a larger scale. Instead of 007, we're going to use 00700. And that's going to bring that actor up 700 units. And if we press play, we can see it up there at 00700. Now, I'd like this other actor, our other debug actor that's drawn with a blue box, to be at 430, but we're scaling up by 100. So we're going to set its location at 400, 300, 0. So it's down there near the floor. And if we press play, now we can see what that looks like. Now, in the vector example in the previous video, we drew a vector from the sniper down to the victim. And that's what I'd like some practice doing. Now, to make things a little bit more clear, I'm going to select the debug actor up here, and I'm going to rename it in the outliner. I'm going to call it DA for debug actor underscore sniper. And I'm going to take the one on the floor down here and call this one DA underscore victim. Now I'd like to draw some debug shapes. I'd like to draw an arrow from the sniper to the victim. And we'll do this from the level blueprint. So I'm going to go back into the basic map. Now we've seen that we can draw debug shapes every frame, and then we don't have to worry about giving them a time limit. So I'm going to move the draw debug coordinate system down to the event tick node and hook it up and set its duration to 0. And that way we'll be drawing it every frame and it'll never go away. And we'll do that for the arrow that we'd like to draw. Now I'd like to draw the arrow from the sniper to the victim. And we can get a reference to an actor in the level by selecting that actor in the level and coming back to the level blueprint, right-clicking in the event graph, and we see that the option exists to create a reference to that actor. So if I select Create Reference to DA Sniper, I now have a node here that references that actor. So I'd like a reference to DA Sniper, and I'm going to go back and find DA Victim, select it, and come back to my level blueprint, right-click, and create a reference to DA Victim. Now I have references to both of those actors, and these are actors, therefore we can drag off of them and access variables and functions that belong to those actors. So now we have references to these two actors here in event tick, and what I'd like to do is draw an arrow from the sniper's location to the victim's location. And that's going to be a challenge for you. Draw a debug arrow from the sniper's location down to the victim's location. Play with the parameters on the draw debug arrow function to get that arrow looking how you want it to look. Increase that arrow size so that you can see the arrow's head. Once you've done that, change your blueprint logic so that the arrow now points from the victim to the sniper. Go ahead and pause the video and get some practice drawing that debug arrow now. Okay, so we're going to want to draw a debug arrow from here in the basic map. So I'm going to use draw debug arrow. We're going to hook this on up, and we're drawing this in event tick, so we don't need a duration. I'm going to set the line color to a nice red, and for the arrow size, I'm going to increase this. I'm going to give it about 250. This will give us a bigger arrow head. Now for line start, I want this arrow to start at the sniper. So I'm going to take my reference to the sniper actor, drag off of it, and get actor location. And this will be the location vector that I pass in to line start. And the line end is going to be the location of the victim. So I need to use get actor location on the victim as well. So that's going to be the line end. So I can play test this, and I can see my arrow. It's a bit thin, so I may need to increase the thickness just a bit. But I can see the arrow, it's there. I'm going to set the thickness to 3. I'm going to change the arrow size as well. Let's make it about 500 and see what that looks like. There's a nice big arrow. Now to draw the arrow from the victim to the sniper, we've seen that all we need to do is reverse that direction. In other words, our sniper is going to be the end of that arrow. So I'm going to break these two nodes, and I'm going to reposition them so that the victim is on the top, and use the victim for the line start, and the sniper for line end. And now we can playtest and see that that arrow is now going from victim to sniper. So this teaches us one important detail. Whenever we have an arrow drawn from a start to an end, all we need to do is swap that start and the end, and we get the exact opposite arrow, the arrow in the opposite direction. And we'll see very soon that this is a very important property that vectors have. So we now have some more practice drawing debug arrows, but we've also learned a few other things. We've learned that we can draw debug shapes with the duration of 0 in event tick, and those shapes will stick around as long as the game is running. We've also seen that we can get references to actors in our world through the event graph in the level blueprint by right-clicking as long as those actor instances are selected in the world. This only works for the level blueprint. We can't do this in any other type of blueprint. We've also learned that we can create variables here in the blueprint editor for blueprints, and we can give them default values, and then we have to compile first before we can set those default values. And we also learned that variables can be instance editable via a checkbox on the details panel, and also with the eye icon. We have two ways to do the same thing. And as long as a variable is instance editable, we can change that variable's value on instances in our level by searching for those variables in the details panel. And we learned that to make that change, we must compile our blueprint before that change becomes apparent on instances in our level. And we've also learned that our blueprints are automatically compiled whenever we playtest by starting a Pi session. So we've learned quite a few additional details aside from just drawing arrows from one location to another. Excellent job, and I'll see you in the next video.